Hi everyone. I can see there's quite a few of you that have joined us already, so that's great. My name's Anthony, another consultant here at Westpoint, Cyber Talent. We're back in the office now. I know the other members of the team have run a few of the events kind of working from home for the last week, so it's good to have ourselves back in the studio here, and got our Christmas decorations up as well. So we've got a really exciting one this week. We've got Alex Hutchinson joining us again. Software architect from Sofecta. Returning to host another webinar today. He's going to be addressing machine learning and AI in cyber and answering the question, do they really add value? I caught a post on Twitter earlier today regarding how machine learning as a feature in cybersecurity products drastically increase profitability. That's great, but does it really help? So as we've kind of done in the past, please submit questions. We have a Q&A section throughout, and kind of at the end, we'll go through those questions with Alex. So without further ado, I'll pass you over to Alex now.
Hi to everybody. Great to see so many people in. Thanks for sharing your time with me. A couple of familiar faces as well. That's nice to see. Great to be back. Thanks again to Westpoint for the invite again to speak. This is a really interesting subject. I find it really this combination of two very interesting subjects. Particularly interesting, and not least the fact that machine learning is so prevalent these days, really across the whole product range, but specifically in terms of cybersecurity. But in essence, it's like up to now, the implementations of machine learning are much more kind of like softer focused areas like image recognition or natural language processing. What we're really talking about in the cybersecurity context is that they're really put to the very front line of defense. And we're going to talk about that. And we're going to talk about the other ways that it's employed as well. But it really is pushing the technology to its limits, and that's really an interesting thing. And I hope you find it interesting anyway. So yeah, machine learning in cybersecurity. These are a few handpicked marketing statements that I've picked. Basically, researching this topic, I went through the kind of top 5, I guess, maybe more, maybe top 10 Gartner rated cybersecurity kind of SIEM EDR providers, kind of looking at how many of them kind of mention machine learning as part of the kind of feature set. The vast majority, it was in there somewhere, to a greater or lesser extent. And some of the wording around the marketing was kind of interesting to see. Particularly this concept of around it being, autonomous artificial intelligence. That one particularly caught my eye as being quite a bold claim. And so we're going to look at really what that really means in reality, in terms of what sort of things we'll be facing kind of in the real world of kind of utilizing machine learning in cyber defense. So first of all, what is machine learning? So I'm not going to go really into too much detail about this, but to say at least that these are two kind of ways of thinking about machine learning algorithms. Firstly, these are two of the main groupings. We're talking about unattended learning algorithms, attended learning, or supervised and unsupervised, to use the other term. And both of these schools of thought basically lend themselves to different use cases in cybersecurity. And they have their own place, and they're used. Both of them are used for different means. So, for example, unattended machine learning, we're talking about putting data in. We have no kind of understanding really of what that data is. Very unstructured. We're putting We're just putting it in to the algorithm, and then the algorithm decides for itself, tries to make sense of what it's looking at, and tries to find something worth saying about it. And that basically means it's used in terms of categorization. It's used in terms of anomaly detection. One of the good things about unattended learning is that that there are no kind of preemptive beliefs basically about the data. You're putting it in. You're not putting your own spin or preconceptions as to what you're hoping to find from the data. You're putting it in and saying that, okay, you tell me what you find in there. And there are positive and negative things with that we're going to look at later. And then of course attended learning, which is about involves a lot more time, putting the time in to labeling data and training the model in the hope that then it will be able to better identify, better predict based on similar data into the future. And some of the things that we're looking at in cyber about this is kind of behavioral analysis and also certain elements of anomaly detection as well. We're going to look at the kind of behavioral analysis things that we're seeing in cybersecurity products in a little while. So, the front line of any cyber security platform, SIEM, EDR, EPP platforms is about the quality of detections. This is the kind of the sharp end of the process, and this is really actually where machine learning is employed the most. So we're going to look at some of the ways that detections are helped with machine learning, or claimed to help. Far and away, the most frequently seen feature involving machine learning is focusing around malware detection. And there are a couple of reasons why. Advanced threats, basically, advanced sort of malware has got very good at circumventing traditional antivirus, as we all know. This is a common reason why we're starting to see advanced protection platforms coming into the market. And there are a couple of ways that machine learning is deployed to better detect malware. One is in terms of analyzing the file hash, MD5 hash, or one of the other hashing mechanisms. And the other way is about actually analyzing the binary file itself. And that's done by not the same way that you might think in terms of literally analyzing the data. This is actually a picture of two malware files, in essence. Now, if perhaps at some point you've opened a binary file in a text editor by mistake, this is the kind of thing you'll see. It's a textual representation of the binary data, and what the machine learning algorithm tries to do is tries to, on a image recognition basis, actually identify how alike these two files are. A lot of malware developers are kind of offering now kind of white label malware ransomware products. They sell the code base, and then they give you some instructions that, okay, you build it with certain parameters. What you end up with is a completely new and unique malware, although the actual file code base is actually only changed a little bit. So if we're looking at this, machine learning is very, very effective at to within an acceptable percentage range deciding how alike these two files are. So we as humans, can we look at these two pictures and decide, would you be able to analyze these and say, okay, well, they're both malware, or one is and one isn't? I'll give you a couple of minutes to look at the pictures. The truth is that I cheated here. They're both identical. And the fact is that, by saying, okay, how much alike are these two files, you're already starting to see differences in the files yourself, which is why humans are not very good at this process. We're gifted with things like preconceptions, which have a habit of bending the truth. Machine learning is invaluable at this process, and is very, very effective actually, which is why it's one of the biggest areas for malware detection. So we're going to start going through some kind of other use cases and thinking about how alike or how much machine learning kind of helps with these things. So, well, this will be an unfortunate kind of set of circumstances. Something has happened, but there's no detection of it anywhere. How do we go about dealing with it? The reason is that advanced threats, of course, have got very good about not leaving any trace in system logs anywhere. Fileless attacks, of course, it's about abusing system software, and they're able to avoid appearing in logs. So how are they ever discovered? How are they ever found? A lot of the time, anomaly detection is used basically in these kind of circumstances. And what it is about is it's about kind of not that there's anything unusual in the logs, but it's about the order of log writing, and is there some correlation between metrics on certain servers and the order of log writing, or is there anything? And it could be some. The point is that it's impossible for a human being to kind of notice something that is probably very, very insipid and hard to detect. Machine learning is deployed to spot the unspottable in essence. So these are a couple of kind of techniques, machine learning terminology here. Clustering, which is essentially again about a categorization. Often it's an unattended technique, basically. So it doesn't need to know anything about the structure of the data. It just does its thing. And it does its thing by essentially kind of ordering what it's seeing into recognizable categories, and then telling you about what categories there is and if there's something that falls outside of what it recognizes. Then the neural network, which is essentially a supervised learning technique. This involves about building a model. So it involves you essentially telling what an anomaly looks like, in essence, and being able to define on the log level what an anomaly might look like. And of course, well, that it might not be too easy to do. Sometimes it is easy. It really depends on the use case. So another use case, a user that logs in, logs out at specific times to specific software. Is there something unusual about it? And this is where behavioral modeling is employed. And this is kind of tricky because really this involves models that are built based on your own company's data or your own organization's data. So it involves more often than not attended models. You have to go there, you have to define what is normal behavior, what is not normal behavior, by essentially looking at the anomalies that it picks and deciding is this weird or not. The reason this is so powerful with machine learning is that traditionally detection layer, we're talking about the writing of detection rules, which are essentially like database queries. We're querying data, in this case log data, and if anybody has done extensive kind of database, SQL kind of queries and stuff like that. It's fine for kind of simple use cases, but let's say if we write a statement, okay, it's going to be, I think that if a user logs in between midnight and 4 a.m., I want to know about it. There must be something unusual. Okay, then what about if the user logs in at 11:59, or and then again at 4:01 in the morning? Then it's not flagged. Which is why it's actually very, very difficult to define in a query effectively, to take account of really in the real world what would be defined as anomalous. So machine learning is great at that, about looking at the data and deciding, okay, well this follows the same pattern to a certain degree of correctness. And then it alerts based on those things, basically how much something looks like a set of events that it's seen before. So this is some of the classifications that are used. Behavioral modeling is used not just in terms of user behavior, but system behavior. So we're talking about how servers and network appliances and IoT devices, how they all interact together. The complete correlation of log data of everything together, and how the system as a whole is behaving. It's very good at doing those things. Something that is impossible really to do as an analyst sat there looking at log streams. So that's the stuff about detection layer. That's really the most important area, but arguably. Some of the other ways it's used is in terms of kind of UI usability things and stuff about helping with the cybersecurity and analysis workflow as well. And it's used also in a lot of these areas, kind of more traditional sort of traditional kind of use cases for machine learning. Again, we'll look at some concrete kind of use cases. So, well, this is a common complaint of security analysts. Perhaps you'll agree. Ping me if you don't agree, but I'm sure that you probably do. So this is about kind of like next layer alerting. In essence, this is about kind of like the machine learning taking on the role of going through vast amounts of alerts, closing false alarms, and basically operating on a kind of a second layer alerting. So we're alerting based on analysis of alerts, not alerting based on the actual findings, the actual alerts that come in, because traditionally there's so many, and anomaly detection is starting to be deployed in terms of a kind of second layer alerting, essentially anomaly detection. If there's 100 alerts a day and there's significantly less or more or a different set of alerts, then that might be then something to indicate a genuine alert. So how much do we agree about this statement? Alert triage. So we're talking about the analysis of alerts, as I mentioned, like looking at the analysis of the alert, what data has triggered the alert, and correlating across the rest of your data streams. So in reality, it means writing lots of queries. Is it difficult? Is it hard? It depends on the platform, depends on your knowledge of the syntax. For most people, it can be tricky. writing complex correlation queries. It can take a lot of time. So this is where AI and natural language detection, natural language processing is being deployed, basically as a kind of like a kind of bot in the UI, basically to basically process what to try and convert plain English into a query in the correct syntax, and something that is actually very, very good at, because natural language detection, as I mentioned, is one of the more mature machine learning kind of tools and processes. It's getting very, very effective at interpreting what you're wanting to what you're trying to mean, in essence. Right. Another use case, I remember there was a ticket about this months ago. So this is about seeing something that that's been dealt with. It's been seen before. It's been resolved. But what was where was it? Where was the ticket? Where was the resolution? And again, AI is being utilized as a kind of recommendation tool to find through the cases that have been logged, and some of the background properties or indications of compromise values that have been put into the tickets, and is there something similar? And again, it just helps with the workflow, and again, which means that the user interface is easier, it's nicer to use, and quicker, more effective, etc., etc. Right. So the prediction end. So this is kind of like looking at a little bit more of the future. We have quite a long way to go in terms of prediction. Can we proactively stop something before it's even happened, in essence? And again, supervised anomaly detection is being used in this context. So but we're looking at things that are going to develop really into the future. It's a fascinating area, and it's kind of like the holy grail of cybersecurity, really. Is about the prediction of things, but it ultimately means putting effort into building a model yourself. So doesn't it sound amazing? So on face value, reading the marketing literature, yeah, it does, but what about some of the realities, some of the real world ways of using it, and is there challenges, is there things to be aware of before we all start quitting our jobs and letting the robots do our work for us? Of course there is. So one of the main things to take account of is the quality of the model. Be this your own model, a model that is developed locally on your own on-prem platform, or is it a model which is deployed with the platform? Same applies. How good the model is really key. Equally, how good and complete your own data is of course absolutely critical. No matter how good the model is, if the data that it is being used against is poor or incomplete, then you're not going to be utilizing the great model to its full potential. So they're both important. Getting the full complete overview of log data, for instance, of your organization into a SIEM EDR platform is of course really key. Another thing is who develops the models. Is it you? Is it the EDR SIEM or cyber platform provider? How have they developed? How big is the training data sets? How How long is it trained for? These are things, you never see any information about this reading marketing literature. I mean, I'd imagine that you have to go quite deep into the sales process before you start getting information about these things. But it's worth bearing in mind and asking, because they're not things that you can take for granted, that one provider might be significantly better than another. Another one is, how often is the model deployed? Does the model sit on your network? Is it developed on your network, or does it get deployed with each platform update? It's good to understand, because a static model, again, is only going to be good for so long. It needs to be retrained on a regular basis, redeployed, and that's something maybe most of all really ought to be asked of your providers. Supervised or unsupervised question. So, this has impacts on the amount of time that you need to put in. It has impacts over the quality of what comes out. It's kind of one of those, you get in what you get out what you put in terms of model development. If you're developing the model yourself as an organization. And then finally, before we kind of go over to questions, basically, I would imagine that machine learning is becoming so widespread, and I think that I would urge really everybody, whether you have a cybersecurity platform, you manage one, or you're looking to buy one, or I would just inform yourself about a little bit more about the machine learning process and its role in the platform, and learn a little bit about it, because if the platform is offering any more than just malware detection, then it might involve quite a bit of work, and it's about understanding and monitoring your expectations based on those things. So that's about it for me. That's all I have to say. So over to the Q&A.
Thanks, Alex. That was a really fantastic talk. Thank you, mate. I really enjoyed that, and I'm sure all our Cyber Lounge audience did as well. A lot of really valuable info to kind of take from that one. As Alex said, it's Q&A time now. So please feel free to submit your questions. I did see one come in kind of during the chat there. Let's see if we can get that one there. So I think it was around the unattended learning. So Aaron's put there, he's a bit puzzled by the statement, unattended learning eliminates the bias which humans bring to the data analysis. Doesn't that just push the bias effect back up the chain to the assumptions of the developers of the algorithm?
Yeah, good point. I mean, the reality is, ultimately, certainly in the machine cybersecurity context, is that we're ultimately left with working with a standard set of algorithms. So, you kind of, even if there is functionality that allows you to start building your own machine learning jobs, generally the functionality is split into those two choices. Do you want it to be attended? Do you want it to be unattended? And regardless of which one you pick, it will probably pick, there'll be an algorithm, or maybe several, that it will use, and it's not something you can affect. So the best we have is to choose between those two things. If you're unsure of the questions that you want to ask, then really it's a case of an unattended model, basically, that you'd be looking to build. But if you know what you're looking for, and you know what you want it to identify, then an an attended model will be probably the best way to go. As to the quality of the results, well, that's really that's hard to say. It's be on a case by case basis, really. Which one is right? Great question, though.
Perfect. Yeah, thanks for that, Aaron. Let's say, yeah, hopefully that that kind of clears that out. Yeah, he's put on there. Thanks for that. So yeah, brilliant, Alex.
No problems.
So we've got an anonymous question here. They put a stupid question. I'm not sure.
No such thing.
But no, I was going to say, yeah, that certainly can help me myself out as well. How does cyber AI fit into machine learning? Models made and improved by AI as opposed to models made by a human?
So models made by, so AI built models we're talking about. So yeah, that's again, it's about yeah, it's about the kind of, ultimately there has to be there's always still a role for a human being to come in and kind of help train the model, or help choose which field properties that we're going to pick for our unattended model. I mean, there always has to be input. So I would argue that there's more value in human involvement than this concept of it being fully autonomous as it stands. I think we're still quite a long way away from this in inverted commas autonomous artificial intelligence, certainly in cybersecurity field. Yeah, it's a fantastic tool, but artificial intelligence and machine learning, you know, we're kind of course, two different things, really. Both are employed for different things.
Brilliant. Yeah, so yeah, hope that one helps there. So we got a reply there from Aaron. It says this is a bit more obscure. So he started off with, according to Socrates, to know thyself is the beginning of wisdom. Are there any solutions achieving wisdom by actually providing the same ML/AI insight into internal rules, rules updates when they are learning from ongoing data streams?
Yeah, so you're talking about, basically adaptive detection rules, perhaps. It's a great concept. In essence, we have machine learning kind of overtakes the kind of detection, overrides the kind of detection rule, the need for detection rules ultimately. If you have a static, let's say, destination IP detection rule, you have a list of blacklisted IPs. Can machine learning be implemented in the same way, basically to kind of on a kind of IP address space kind of level, for instance, detects how is an IP address that we're seeing in the same address space? And yeah, I'm sure it would help for that kind of case. We don't have to write a complex query which is involving breaking down basically address spaces into individual IP addresses and then checking against the value and stuff like that. It'd be, yeah, nice idea. I think I quite like that idea, actually.
Brilliant. No, thanks, Aaron. So hopefully that kind of cleared up a little bit. So it seems to kind of got you thinking a little bit, Alex, which is nice.
Yeah.
Brilliant. Yeah, let us know if that clears that one up, Alex. Pete Stockley has asked another question there. He said, Alex, which sources do you use, or would you recommend following in order to stay up to date with AI developments?
Yeah, so there's a couple of one of the best ways is really by kind of looking at the kind of cybersecurity kind of websites basically for each cybersecurity providers, and looking at the basically the features that they have on offer, and some checking what updates they have coming up. Outside of that, really, is if we're talking about general machine learning and AI kind of developments, then yeah, I'll get back to you on that one. Say I'm not a data scientist. That's the thing. So I think there's a lot of good white papers and stuff like that, which aims to help. But I know Pete is a good friend, so I can help him out on that one.
Cool, perfect. Okay, so another one here. Would you feel confident freezing or blacklisting software automatically based on a machine learning models detection?
Yes, I would. Very much so. And the reason is that as I mentioned, it's a very mature kind of area. So particularly on the image recognition technique, which is being used, it's very, very effective, even more effective than analyzing the contents of a file. It's a lot quicker and a lot more effective. So and plus most EDR platforms, for instance, they allow you to be able to set a kind of a parameter that, okay, I need to be 90% sure that it is malware or not. It is 90% similar to an identified malware instance. You can set those parameters yourself. So, based on your own kind of comfort, your own kind of comfort setting, how aggressively you want to blacklist and freeze processes or not. So, yes, is the answer.
Brilliant. Okay, next one. So do any platforms help the user to build machine learning models? It sounds complicated.
Yeah. Well, I guess the answer is that it's not that complicated, actually. And yes, there is in most sort of EDR and SIEM platform that obviously offer the chance for you to be able to build your own models and your own kind of machine learning analysis. Then yes, they do offer a kind of a click through kind of process of building a model. 9 times out of 10, like I mentioned, you don't get to choose the algorithm. That's done for you, because that is it's a complex area. But in essence, you pick from your log data the fields that you want to analyze. Picking one is probably best. Let's say for instance, destination IP, for instance, being one. So we can analyze internet IPs that are being connected to from your network, for instance. And if you're adding more than one property, then it starts to get more complicated, and the quality of the insight starts to become more difficult. So yeah, so yes, there is wizards, and it allows you to it follows you through the process quite well, I think. So machine learning is so much more of an art than a science. It's about kind of experimenting.
Brilliant. Brilliant. No, thanks again. Okay, and what tips could you give regarding building a machine learning model for analyzing company user behavior?
Company user behavior. So we're talking, yeah, behavioral sort of analytics. So first of all, I would recommend to be very, very specific. Don't sort of go with the idea that, well, you say to the model, well, tell me what's weird in my data. Most times you're not going to get too insightful answers. It needs to be, the questions you ask need to be very specific. So it needs to be focus on something, and focus on your logs and think about how, from what log fields will I find what I'm looking for. So whether it's, as I say, IPs or the host names, domains being connected to external network domains that you want to analyze. When are they being connected to? Timestamp data in the log. That's already two very good fields. That might be more than enough for you to answer. Like, tell me something that is anomalous relating to our staff's use of the internet. Essentially, I mean, this is what we're saying. Is there something anomalous about where people are connecting to? So yeah, be specific and be realistic, I guess, will be the answer.
Yep, spot on. Perfect. Okay, and we've got another one here from Henry. Is there any regulation in place governing the use of AI within cybersecurity, bearing in mind the potential in using this tech by state actors?
It's a great question. Not to my knowledge, because that would be, of course, potentially a great quality assurance kind of mechanism, I suppose. And to my knowledge, there doesn't exist. If I'm wrong, then please get in touch and tell me. But I've not come across anything really in terms of regulatory compliance to do with machine learning.
I guess with it all being so new, isn't it? They just
maybe, yeah. And of course, the question is how would you validate? How would you regulate? And quite a complicated process to decide whether a model is well trained enough or not. Yeah, quite a minefield. It's above my pay grade.
Yeah, it would certainly be down to interpretation, I guess, wouldn't it? And like I say.
Yeah, exactly. Yeah. Interesting question. Thank you.
Yeah, brilliant. I think that's the last of the questions. Fire something in kind of last second here if you've still got a few seconds now. But so I think if there isn't any more, we're pretty much kind of ready to finish up. Obviously, massive thank you to Alex, for giving us another, amazing event. Really, really insightful. We will definitely be kind of sending this out to everybody shortly. And obviously a big thank you to you guys, the audience, for attending. We have got another event coming up next week where we'll be talking about how to kind of map out your cyber career. So whether you're in the very beginning, early stages, or want to know kind of where cyber can take you, or if you feel you're kind of stuck in the middle of your career and kind of how to progress and kind of make that next step. But as I kind of said, we'll send the link out to you for this one here today with Alex, along with the recording. In the meantime, make sure you kind of follow us here at Westpoint Cyber Talent, kind of on LinkedIn, and Alex Hutchinson as well, and Sofecta. So again, thanks again, Alex. Pleasure having you here, and hopefully look forward to seeing you all again soon.